Air traffic control, also known as ATC, is the backbone of modern safe air travel. ATC is a service provided by ground-based air traffic controllers who direct aircraft on the ground and through controlled airspace, and can provide advisory services to aircraft and non-controlled airspace. The primary purpose of ATC worldwide is to prevent collisions, organize the flow of air traffic, and provide information and other support for pilots. In some countries, ATC plays a security or defensive role, or is operated by the military. To prevent collisions, ATC enforces traffic separation rules which ensure each aircraft maintains a minimum amount of empty space around it at all times. Many aircraft also have collision avoidance systems, which provide additional safety by warning pilots when other aircraft get too close. In many countries, ATC provides services to all private, military, and commercial aircraft operating within its airspace. Depending on the type of flight and the class of airspace, ATC may issue instructions that pilots are required to obey, or advisories that pilots may, at their discretion, and disregard. The pilot in command is the final authority for safe operation of the aircraft and may, in an emergency, deviate from ATC instructions to the extent required to maintain safe operation of their aircraft. First radar sets were introduced at Croydon Airport in the 1920s. This was put in place to make sure that aircraft could arrive safely. What would happen is that there were 3 radar antennas in few different areas. Then the ATC controllers will take those coordinates and then find where the plane is going. The primary method of controlling the immediate airport environment is visual observation from the airport control tower. The tower is a tall, windowed structure located on the airport grounds. Air traffic controllers are responsible for the separation and the efficient movement of aircraft and vehicles operating on the taxiways and runways of the airport itself, and aircraft in the air near the airport, generally 5 to 10 nautical miles away, 9 to 18 kilometers, depending on the airport procedures. Surveillance displays are also available to controllers at larger airports to assist with controlling air traffic. Controllers may use the radar system called secondary surveillance radar for airborne traffic approaching and departing. These displays include a map of the area, the position of various aircraft, and data tags that include aircraft identification, speed, altitude, and other information described in local procedures. In adverse weather conditions, the tower controllers may also use surface movement radar, SMR, Surface Movement Radar Guidance and Control Systems, SMGCS, or Advanced SMGCS to control traffic on the maneuvering area, taxiways, and runways. The areas of responsibility for tower controllers fall into 3 general operational disciplines: local control or air control, ground control and flight data, clearance delivery, and other categories such as apron control or ground movement planners may exist at an extremely busy airport. While each tower may have unique airport procedures, such as multiple teams of controllers at major or complex airports with multiple runways, the following provides a general concept of the delegation and responsibilities within a tower environment. After the plane lands, its responsibility is handed over to ground control, also sometimes known as ground movement control, is responsible for the airport movement areas as well as areas not released to airlines or other users. This generally includes taxiways, inactive runways, holding areas, and some transitional aprons or intersections where aircraft arrive having vacated the runway or departure gate. Exact areas and control responsibilities are clearly defined in local documents and agreements at each airport. Any aircraft, vehicle, or person walking or working in these areas is required to have clearance from ground control. This is normally done via VHF or UHF radio, but there may be special cases where other procedures are used. Aircraft or vehicles without radios must respond to ATC instructions via aviation light signals or else be led by vehicles with radios. People working on the airport surface normally have a communications link through which they can communicate with ground control, commonly either with a handheld radio or even a cell phone. Ground control is vital to the smooth operation of an airport because this position impacts the sequencing of departure aircraft, affecting the safety and efficiency of the airport's operation. Some busier airports have surface movement radar (SMR), such as AST-3, AMASS, or ASDE-X, designed to display aircraft and vehicles on the ground. These are used by ground control as an additional tool to control ground traffic, particularly at night or in poor visibility. There are a wide range of capabilities on these systems as they are being modernized. Older systems will display a map of the airport and a target. Newer systems include the capability to display higher quality mapping, radar targets, data blocks, and safety alerts, and to interface with other systems such as digital flight strips. Air traffic controllers work in facilities called air traffic control centers, each of which commonly referred to as a center. Each center is responsible for many thousands of square miles of airspace, known as Flight Information Region, and for airports within that airspace. Centers control IFR aircraft from the first time they depart from an airport or terminal area's airspace to the time they arrive in another airport or terminal area's airspace. Centers may also pick up VFR aircraft that are already airborne and integrate them into the IFR system. These aircraft must, however, remain VFR until the center provides a clearance. Center controllers are responsible for issuing instructions to pilots to climb their aircraft to assigned altitude while at the same time ensuring that the aircraft is properly separated from other aircraft in the immediate area. Additionally, the aircraft must be placed in a flow consistent with the aircraft's route of flying. This effort is complicated by the crossing of air traffic, severe weather, special missions that require large airspace allocations and traffic density. When the aircraft approaches its destination, the center is responsible for issuing instructions to pilots so they will meet the altitude restrictions by specific points, as well as providing many destination airports with a traffic flow, which prohibits all of the arrivals being bunched up together. These flow restrictions often begin in the middle of the route, as controllers would position aircraft landing in the same destination so that when aircraft are close to their destination, they are sequenced. As an aircraft reaches the boundary of a center's control area, it is handed off or handed over to the next area control center. In some cases, this handoff involves a transfer of identification and the details between controllers so that air traffic control services can be provided in a seamless manner. In other cases, local agreements will allow silent handovers, such as a receiving center does not require any coordination if traffic is present in an agreed manner. After, the aircraft is given a frequency change and begins talking to the next controller. This process continues until the aircraft is handed off to a terminal controller. To make the job of controlling all the flights in the air a lot simpler, what ATC does, it makes call signs. These are permanently allocated by the ICAO on request, usually to scheduled flights and some air forces and other military services or for military flight. They are written call signs with a three-letter combination like KLM, BAW, VLG, followed by a flight number like AAL 872, VLG 1011. As such, they appear on flight plans and ATC radar labels. There are also the audio or radio telephony call signs used on radio contact between pilots and air traffic control. These are not always identical to their written counterparts. As an example of an audio call sign would be Speedbird 832 instead of the written BAW 832. This is used to reduce the chance of confusion between ATC and the aircraft. Day-to-day problems faced by air traffic control system are primarily related to volume of air traffic demand placed on the system and weather. Several factors dictate the amount of traffic that can land at an airport in a given amount of time. Each landing aircraft must touch down and then exit the runway before the next crosses the approach end of the runway. This process requires at least 1 and up to 4 minutes for each aircraft, allowing for departures between arrivals. Each runway thus can handle 30 arrivals per hour for an airport like San Diego. A large airport with 2 arrival runways can handle about 60 arrivals per hour in good weather. Problems begin when airlines schedule more arrivals into an airport than can physically be handled, or when delays elsewhere cause groups of aircraft that otherwise would be separated in time to arrive simultaneously. Aircraft then must be delayed in air holding by occupied locations until they may be safely sequenced to the runway. Up till the 1990s, holding, which has significant environmental and cost implications, was a routine occurrence at many airports. Advances in computers now allow sequencing of planes hours in advance. Thus, planes can be delayed before they even take off by being given a slot, or may reduce the speed in flight and proceed more slowly, thus significantly reducing the amount of holding. Beyond runway capacity issues, the weather is a major factor in traffic capacity. Rain, ice, snow, or hail on the runway cause landing aircraft to take longer to slow and exit, thus reducing the safe arrival rate and requiring more space between landing aircraft. Fog also requires a decrease in the landing rate. These, in turn, increase airborne delay for holding aircraft. If more aircraft are scheduled than can be safely and efficiently held in the air, the ground delay program may be established, delaying the aircraft on the ground before departure due to conditions at the arrival airport. In area control centers, a major weather problem is thunderstorms, which present a variety of hazards to an aircraft. Aircraft will deviate around storms, reducing the capacity of the en route system by requiring more space per aircraft or causing congestion as many aircraft try to move through a single hole in the line of thunderstorms. Occasionally, weather causes delays to aircraft prior to the departures as routes are closed by thunderstorms. Much money has been spent on creating software to streamline the process. However, at some ATCs, the air traffic controllers still record data for each flight on strips of paper and personally coordinate their path. In newer sites, these flight progress strips have been replaced by electronic data presented on computer screens as new equipment is brought in, and more sites are upgrading away from paper flight strips. In all, ATC is the key in making sure that all people make it to their destinations on time and safely. Thanks for watching this long on video, and also please watch some of my other on videos. Again, thanks for watching, and see you in the next one.